I'll now go over question 4 in exam 3. A block of mass 6.0 kilograms is pushed a distance of 5.00 meters along a 30.0 degree rough inclined plane with an applied force along the incline of 50.0 newtons. The force of friction between the block and the surface is F sub k equal to 17.8 newtons. In part A, we're to state the energy principle for the system that contains only the block. That is, all forces are external to the system. Assuming the block starts from rest and ends with some final velocity v sub I. Don't put in any numbers, but do indicate if any of the terms are zero. Put a line through them. Okay, so here we have, if I were to draw a system, the only object in our system is the block. The earth is out of our system. The friction force is out of our system. And the external agent, F sub p, is out of our system. So, the energy principle, that is the work done by external forces, is equal to the work done by F sub p plus the work done by the gravitational force plus the work done by friction. And that's going to change the kinetic energy of our system. Now, to identify the work done by these forces acting on our object, it's useful to draw a free body diagram. So we have F sub p acting in the direction of the incline, and we have F sub k acting negative in the negative direction relative to the direction of F sub p. We have a normal force which does no work because it's perpendicular to the displacement. And we have also acting down the incline, we have the component of the gravitational force, mg sine theta. And I should say that the normal force is balanced by mg cosine theta. Okay, so we can rewrite this work F sub p as F sub p times the displacement d, which is given 5.00 meters, plus the work done by gravity, which is minus mg sine theta, times d, plus the work done by friction, which is minus F sub k times d. And that's equal to the final kinetic energy minus the initial kinetic energy, which is 1/2 mv final squared minus 1/2 mv initial squared. But this kinetic energy is 0. So that's part A, what I was looking for an answer to part A. In part B, we want to find the work, W sub P, done by the external force, the 50 Newton external force applied over the 5.00 meters. So we've already written that down above. That's equal to F sub P times D, which is equal to 50.0 newtons times the displacement 5.00 meters. And that's then 250 joules. Part C asks, find the energy lost by the friction over the 5.00 meters. So that's what is the work done by the friction. The work done by the friction force is minus F sub K D, which is equal to minus 17.8 newtons times 5.00 meters, which is equal to minus 89.0 joules. And then in part D, we're asked to use the energy principle to determine the final speed of the blot, v sub F. Well, we've already written down an equation for the energy principle in part A, so we write it down again. F sub P times G minus mg sine theta D minus F sub K D is equal to 1/2 mv squared. So that's 250 joules, which we calculated in part B, minus the mass, which is 6.0 kilograms, times G, which is 9.0 meters per second squared, times the sine of 30 degrees, which is 1/2, times the distance, D, which is 5.00 meters, minus F sub K times D. We've already calculated that. So it's minus 89.0 joules. And that's equal to 14.0 joules. Which is equal to 1/2 mv final squared. So V final is equal to the square root of 2 times 14.0 joules divided by 6.0 kilograms. And that's equal to 2.16 meters per second. And that concludes this video.